Hi, and welcome to another Hopper on microcontrollers video. This one's about the shell and, more to the point, getting the shell to actually run on a device other than Windows. So the shell is the sort of container application here, command line for want of it. And you can do things in the shell. There's commands like the ones you're used to looking at the directory, so dir or ls are both aliases, or change directory, clear the screen, delete something, etc. Right. You're in Windows because I've got color in the shell, and there's a couple of other reasons as well. And each of these shell commands, if we just look over here, in this folder, the shell folder, there's the source code to all these commands. So if I look at the directory command, this is what it looks like. Hopper is a modern curly brace and semicolon language like Java or C#, garbage collected, etc., but just made to run on small devices efficiently, like this Raspberry Pi Pico that I'm going to demonstrate on today. So how does the shell work? Well, if we look at the shell source code, right here, the way it runs one of these commands is it executes it. So it chains it. And recently I finished implementing that for the Portable Runtime, which is the runtime that runs on devices other than Windows. The Portable Runtime is about 10,000 lines. It's written in Hopper. It's about 10,000 lines of Hopper. Actually, about 8,000 lines of Hopper and about 2,000 lines of platform-specific C code. And in this case, I used the Arduino IDE, and the platform-specific code is where it figures out how the file system works. In this case, I'm using the internal flash of this Raspberry Pi Pico, where to get a big chunk of memory from, how to talk to the serial ports, that sort of thing. Serial devices like SPI, I2C, or UART. Anyway, one of the interesting things you can do with the shell is you can launch itself. You can do it again. And if I exit from that one, and I exit from that one, I'm back at the top one again. Right? So you can do that in the Portable Runtime now as well. So once I got that run execute working, I made a version of the shell that works on the serial port. So it's not in color, it's green only, it's only one color. And it's less functional because you can't move the cursor around as easily in a serial window, in a serial port window. But I have an app, there's a Hopper app called Term here, which is a terminal UI. It asks me which COM port, because I could have more than one board connected. That's the one. And what we've just connected to is on that Raspberry Pi Pico is the Portable Runtime shell running. That's what this is. So if I type help here, it will be in green. This is actually the serial port connected to that device. So it has a file system. So if I go dir, if we want to know about help for dir or help for ls, they're aliases. -s recurse into subdirectories. So let's do that. dir-s. Let's see what's on my flash. So I only have 3 folders on my built-in flash in this Raspberry Pi Pico. This code's all running on the Pico. It's just a serial connection, and it's all written in Hopper. So it has the root folder. It has a folder called basic, which has some basic samples, and it has a bin folder, which has some programs I've already uploaded to it, including these shell programs, the dir, which I'm running right now. I've got a Mandelbrot example, and then I've got something called TiggerBasic. TiggerBasic is my port of Gordon Henderson's GIBL Tiny Basic, pretty true to the language, but I've ported it to run on the microcontroller. So if I launch TiggerBasic, we're now in another console, but we can see it doesn't have a little slash in front of it. So now we're in BASIC. So we can do things like, say, print hello. BASIC has a REPL for you Python programmers. I can do 10 for I equals 0 to 100. Parents. I is I 30 next I. Now I think that when I run it, I've got it set up so that the built-in LED on this microcontroller will light up green while it's running. So let's see if it does. Yes, it does. Very quickly though. So I'll do that again. We can do a listing. There's our source code. And if I run it again, we should see the green light built-in LED on the Pi Pico light up briefly. There it did. Okay. So it's also got a dir command. The basic one just iterates what's in the basic samples folder. And again, the Mandelbrot is one of Gordon's originals. So if I just go load, and it only looks in this folder, so it's going to find it by default. It's going to find the right folder. Mandel bench. It's loaded it. Let's look at it. There we go. So this basic interpreter, it tokenizes into Hopper virtual machine bytecodes. So it's actually pretty fast for a basic. So let's run Gordon's Mandelbrot example here. Again, we see the green light light up. I can do that again. So the green light, I've got it so that it turns on while it's running and turns off when it's done, just so that you can see we're actually running on the microcontroller. So it's taking like 1.3 seconds to do Gordon's Mandelbrot. I've also got the Byte Magazine 1983 benchmark prime sieve. So let's run that one too. We'll see the green light light up again. Doing 10 iterations, we get 1 dot per iteration up there. And then the green light's out, and that took 0.4 seconds. It's actually a pretty fast version of this benchmark as well. Anyway, so we know that Gordon's Mandelbrot took 1.3 seconds when running in this interpreted language sitting on top of Hopper. So this is an interpreted basic running on the Hopper virtual machine, running on the Pi Pico. So let's exit basic again, and let's see what I had in the bin folder. So I also had a Mandelbrot here that's not basic. It's a Hexi, which is a Hopper executable. So this one's actually written in Hopper. So let's see how fast the Hopper version is compared to the basic version. I don't expect it to be much faster, but I do expect it to be faster, a little bit faster. There we go. So 0.8, call it 0.9 seconds versus 1.3 seconds. So the basic version is about 1.5 times slower, which is not a bad penalty for the fact that that one's interpreted and this one is not. Well, it's also on a virtual machine, so it's executing bytecodes. Anyhow, this is as far as I've got with getting the so you can do that sort of thing, is getting the shell running on the Pico. That program auto there is the primary program on the Pico that it'll run when you restart the Pico. And in this case, auto is actually just the shell. So I'm launching new shells, and if I go exits the shell. There we go. Anyhow, thank you for watching. I look forward to your questions and feedback in the comments. And I'll link to a playlist about getting up and running on a Pi Pico from getting the Windows development environment, which is all written Hopper, up and running, and also to a playlist about the Hopper language.